All right, let's get this started. So welcome to day 2 of cognitive psychology. And what we're going to be doing today is we are going to now do our introduction to the actual subject of cognitive psychology. So last class, we were going over how the class works and kind of alluded to what cognitive psychology is all about with a few demonstrations. And then today, we're going to follow that up by laying down the foundation of the cognitive approach to understanding psychology. So it's important to remember that cognitive psychology does have certain areas that it focuses on more extensively than other areas of psychology, such as it focuses on perception, focuses on attention, focuses on problem solving. But it really is an approach to understanding human thoughts and behavior. Is really an approach to understanding how the human mind works. And that's an important thing that we are going to continually make a distinction with, is that when we are talking about processing and information processing, and how do we take in information and then change that information and then produce either more information or behavior, what we're going to be talking about is the human mind. And that is going to be the focus of our course here. And that's a very important thing to remember and kind of keep forefront in your human mind, especially in your early going, because one of the things that oftentimes happens is people confuse the human mind with the human brain, and they are not the same thing. And this is just something that happens in our culture. So preparing for this lecture, I Googled images of the human mind, and you can see that Google basically in every single instance has some connection between the mind and the brain, or some idea that the human mind is the human brain. And we're going to see instances in this course where that is partly true. Some of the information processing that you do is done in the brain, but some of the information processing is done in relation to the environment. Some of the information processing is done within your brain and your body. That's known as embodied cognition. So it's very, very important to remember this distinction, that your human mind, what we conceptualize as that entity that processes the information that you then use to create thoughts and behavior, that does not equal the human brain. So the human brain is a very important component of the human mind. The human brain is a way that the human mind is implemented in the real world, but it's very, very important to continually remind yourself, especially in the early going, especially because you have been raised to equate mind with brain. We need to remember that we are not going to be looking at the human brain in order to understand the human mind, because those two are very, very, very separate things. So we're not going to be looking at the human brain in this course very much. You'll see it alluded to oftentimes in the text. In the lectures, we're actually not going to talk too much about brain localization and different areas of specialization. But that doesn't mean that we're not going to talk about what makes up your mind. And today we're going to start off and show you that your mind is not completely made up of one thing, but one thing that it might be made up of is demons. And I don't mean that in the sort of metaphorical, we all have our demons inside us, and you know, when faced with my demons, I clothe them and feed them, nothing like that. But we're going to see that one way of explaining letter recognition, which is a very basic thing that we can all do, is to actually say that, well, maybe your mind actually has demons inside it, and these demons are what allows you to understand and recognize letters. And we will see that counterintuitive idea fleshed out more in this lecture today. All right, so this is going to be your introduction to cognitive psychology. We're going to talk about the information processing approach kind of in general terms, just so that we're very clear on what we mean by information processing, because this is the basic approach to cognitive psychology. If you are using the information processing approach, you are doing cognitive psychology. It doesn't matter if you're doing it with child development. It doesn't matter if you're doing it with personality. It doesn't matter if you're doing it with clinical psychology topics. As long as you're taking that information processing approach, you are doing cognitive psychology. And then we're going to talk about models of the mind, what models are useful for, why do we use models of the human mind. We're going to spend a lot of time today on Mars tri-level hypothesis, which is going to give us a way to know whether or not we understand the human mind and what steps we need to take in order to understand that. And that's going to lead us into the idea of what is a representation, which is also a very, very important basic idea that we're going to be dealing with. And then we're going to take all of that and we're going to apply it to the problem of letter recognition. So this is something that seems very simple. It's something that we can all do. It's something that we all learn to do at a very early age. So I have seen videos of 2-year-old, 3-year-olds who know all of the letters of the alphabet. So how are letters recognized? We're going to take a look at two models. One, the template model, and then the pandemonium model, which is the one that postulates that you have demons inside your mind. And these demons are not whispering to you to do horrible, horrible things. They're whispering to you that that first letter up there, that's an I. And that second letter up there, that's an N. And that's what those demons are communicating to you. And we'll see exactly what we mean by that. All right, so back to the human mind, back to our trying to understand what is going on inside ourselves when we take in information, somehow process that information, combine it, delete it, change it so that we can do intelligent cognitive behavior. What do we mean by that? Well, what we're talking about is the information processing approach. So it's the idea that human cognition, what we consider to be cognition, what we consider to be thinking, what we consider to be problem solving, what we consider to be the kind of core aspects of what it means to be a human and what it means to have human behavior and human thoughts, that can be thought of as information processing, which is another way of saying that your mind is an information processing system, meaning that it takes information in one form, right? So there's some sort of input that is coming into your mind and it processes it into another form. So it takes information in, processes that information in a certain way, and then spits information out. And that is the basic idea of the information processing approach. So let's go through an example of this. So let's say that we have here the human mind. And once again, I'll try to break this as often as I can, but sometimes it's just for illustrative purposes. You put the mind inside the head. That's not where your mind is. Your mind is not your brain. I'll just mention that 400 more times during this course. But anyways, let's say that you have information in the outside world. So you have two vertical lines that you perceive in the outside world, and that goes into your mind. And you have two slanted lines, slanted to the left, that you perceive in the outside world. And that information goes into your mind. And you have two horizontal lines in the outside world, and that information goes into your mind. And then you have two lines slanting to the right, and that information goes into your mind. And then we have further information that goes into your mind as to the location of those particular lines. So we have the two vertical lines, and they are in those two locations. We have the two left slanted lines, and they are in those two locations. The two horizontal lines are in those two locations. The two right slanted lines are in those two locations. So we have more information coming in to your mind. And then we also have information that the thing that you are looking at is red. So that pops into your mind, and your mind puts that all together, somehow processes all that information and says, hey, you know what? I'm looking at something that looks like this. So I am looking at a red octagon. And then more information processing occurs. So you have that red octagon that you have come to that's somehow represented in your mind. And then that is combined with memory that you have represented and stored in your mind. And when you combine that red octagon with your memory of how our society works, you know that what you're looking at is a stop sign. And then further now, you know what behaviors are expected of you depending upon what situation you're in. So are you driving? Are you walking? Those are all meanings, again, that come from this information processing. So once again, we're going to take a look at the mind. And one of the things that you're going to often see is the idea that the mind, as an information processing system, one of the closest analogs to that, or analogies, is that your mind actually works like a computer does. So a computer is an information processing system. Your mind is an information processing system. And the idea was very early on in cognitive psychology that your mind and a computer are basically doing the same thing. They're doing it in certain different ways, but they're basically doing the same thing. And that was unbelievable to a lot of people back in the 60s when cognitive psychology started out. These days, with the advances that we had in AI in just the last 5 years, is becoming more and more believable. As we see more and more artificial intelligence, I like the term alternative intelligence, as we see more and more of this alternative intelligence doing the kinds of things that humans can do, doing the kind of things that we would take a look at a human and say, hey, that was cognition. That person wrote a paragraph about, World War I. That's cognition. That person drew a picture of a man standing on top of a mountain. That's cognition. AI is doing more and more of that, better and better every single day. So this idea that processing information can lead to cognition, we now have a very clear evidence of it, clear proof of concept. Whereas before it was an idea that we had, but again, that idea that we're taking information in and our mind is processing it, and then we're popping information out. That's at the heart of everything that we're going to take a look at here in cognitive psychology. All right, so now we have this idea that we're taking information in, we're doing something to it, and we're putting information out. So what is that doing something to it part of our cognitive information processing approach? Well, that is what our models of the mind is. And that is one of the big tasks as a cognitive psychologist, is to come up with these models that can explain how the information gets in, what happens when it's in there, and then how does the information get out. So models of the mind, these are representations of how your mind works. And you're going to see that a lot of them oftentimes just try to represent one particular aspect of cognition. So there's very few models out there that are entire mind models. And that's because one of the big advantages of models is that they are simpler. They are easier to understand. They're easier to wrap your human mind around. And that therefore they're easier to work with in order to make predictions, in order to create explanations. So that's one of the first advantages of models. So let's give you a concrete example, not of a model of a mind, but a model of something else that hopefully we're all familiar with, which is Earth, more specifically, North America. So this is not North America. This is a model of North America, right? And we actually are standing on North America. And if we tried to understand things about North America just using the actual North America, it would be incredibly difficult, because North America as an external reality is not easy to work with. It's not easy to visualize. It's not easy to understand. But something like that, we can start to understand it a little bit better. But this is still a very complicated model, and it's missing certain information. So if you wanted to know something near and dear to my heart, where's Canada? This is not an easy way to understand where Canada is. However, if you have another model, maybe a little simpler, with different information represented, then all of a sudden we know where Canada is in relation to the United States, and we can see where Mexico is, and a bunch of other countries. So we are able to understand North America a little bit better now, even though we went from a slightly more realistic but more complicated model now to an even simpler model. And if you wanted to even simplify this further, if all you were interested in were the countries, you can simplify that even further. And again, this is not the complete story of North America, but if you wanted to answer the question, which country is furthest north? Is it Mexico, United States, or Canada? This is a great model to understand that. And this is a great way to represent that question, to kind of get to what your mind might be doing when it's trying to understand, for example, spatial relations between countries. So just to kind of drive home the point that we use models because they're simpler, we use models because they help us understand. There was this really, really interesting short story, and by short story, I mean super short, not quite flash fiction, but just one paragraph. So this is by the Argentine short story writer, essay poet and translator, Jorge Luis Borges. And we can actually read the whole thing. It's on exactitude in science. And he writes, in that empire, the art of cartography, so map making, attained such perfection that the map of a single province occupied the entirety of a city, and the map of the empire the entirety of a province. In those times, the unconscionable maps no longer satisfied, and the Cartographers Guild struck a map of the empire whose size was that of the empire, and which coincided point for point with it. So the Cartographers Guild made a map of their empire that was as big as their empire, and it was as detailed as their empire. And if you're thinking about how detailed can a map get, that's the limit, right? You can only get as detailed as the thing that exists. However, the following generations who were not so fond of the study of cartography as their forebears had been, saw that the vast map was useless, and not without some pitilessness was it that they delivered it up to the inclemencies of sun and winters. In the deserts of the West, still today, there are tattered ruins of that map, inhabited by animals and beggars, and in all the land, there is no other relic of the disciplines of geography. So that's just the idea that we need these models in order to understand this very complex thing. And we need to keep the model simple at a level where we can understand it. And if we were ever able to map out the entire human mind, point by point by point, that would actually not be a good thing, because we wouldn't be able to understand what is going on in the human mind if we were able to do that. Much like the map that is the exact same size of the world that you live in is just not a good map for doing the things that maps are trying to do. So again, this is going to be a very, very important thing to remember when we're dealing with these models. They might sound silly, they might sound counterintuitive, they might sound, as we see today, with demons in your mind, preposterous, but the idea is not to have a point-by-point relation to what your mind really is, but it's having a model of the world, model of your mind, much like this model of the world, that is at a level and shows the information and how we use the information that is useful for us to understand the things and the behaviors and the thoughts that we're trying to understand. All right, so advantages of the models and why we use them. They are simpler. Number two, they are a starting point. And by this, I mean they oftentimes suggest the questions to ask. So if you are using a map of, the countries of the world, you can start asking, well, which of these countries is larger? Which of these countries is more densely populated? Where are they more densely populated? Those are all the sorts of questions that would occur when you see a map of the world where the borders are drawn in. All of a sudden, you start asking questions about, well, what are the differences between certain countries? So they serve as a starting point. They suggest questions that might be asked that you might not have thought before. And most importantly, they can be used to understand information processing systems, which means that they can be used to understand how your mind actually works. So that's the idea of using models of the mind in order to understand how your mind actually works. And now we're going to turn to the question of, if we're trying to understand how the mind works, what do we need to do? When can we say that we have a complete understanding of the human mind? Or maybe more realistically, when can we say that we have a complete understanding of one aspect of the human mind? When can we say that we have completed it, we've stuck a fork in it, we understand the complete system? Well, for that, we're going to turn to David Marr. So this is David Marr, and he came up with Marr's tri-level hypothesis. David Marr, he was a neurophysiologist, a neuroscientist. He made a lot of contributions to psychology, artificial intelligence, vision, perception, and he did all of this before dying at the age of 35. So this was one of the brilliant lights of psychology that was just snuffed out too soon. And we're very thankful that he did make the contributions that he did in the short time that he had in this world. And one of his big contributions to cognitive psychology was his idea of the tri-level hypothesis. And what this is the idea that if you want to fully understand an information processing system, i.e., you want to fully understand the human mind, then you have to understand it at 3 distinct levels of analysis. There are 3 levels to this that you need to understand. You need to have an understanding of each of those levels before you can then say, aha, I understand this information processing system, I understand the human mind. So the 3 levels are the computational level, and this is the problem faced in conceptual terms, and we'll talk a little bit about that once we get all 3 levels up here. So we got the computational level, that's the problem faced in conceptual terms. We have the representational level. That is the strategy that may be used in computational terms. So not necessarily the strategy that is used, but the strategy that may be used in computational terms. And then finally, we have the implementation level. And that is how it is actually done in a real physical entity. How is level 1 and level 2 done in an actual real physical thing? So let's talk about each of those in turn, and then we're going to focus most on the representational level. So the computational level, that is the problem faced in conceptual terms. What that means is that the computational level is basically a list of what the human mind can do. And it's mentioned in ways of the information that's coming in or the stimuli that is being input, the behaviors that are coming out in sort of measurable units that can be analyzed, separately. That's what we mean by in computational terms. But in basic idea, this is basically what we can do as human beings. So if we were to make an entire theory of the mind, if we were to make a complete understanding of everything that the human mind can do, our first task at the computational level would be to list everything that the human mind can do. So can the human mind recognize letters? Yes, it can. So that goes into the computational level. Can the human mind summarize large texts? Yes, it can. That goes into the computational level. Can the human mind allow you to navigate this world without falling over and losing your balance? Yes, it can. That goes into the computational level. Can the human mind read a map? Yes, computational level. Can the human mind plan ahead and make sure that you have all your assignments done by Sunday night at midnight? Yes, it can. That goes into the computational level. Basically, anything that your human mind can do would go into the computational level, and it would be described in a way where you can break it down into little component parts, right? It would be described in a way where it's made up of little pieces of information or little behaviors that we can then combine. That's what we mean by in conceptual terms. Sorry, not computational terms, in conceptual terms. But again, this is the problem that is faced. This is what you can do. The next station is, or the next level is the representational level. And this is the strategy that may be used. And this is in computational terms. So this is as an information processing system. So the strategy that may be used, we're going to talk about that in just a moment. And that is what this course is going to be about. Very little of the computational level. We will talk a little bit about what the mind can do. 98% representational level. What is the strategy by which your mind accomplishes the stuff that we list in the computational level? And then finally, what we're not going to be talking about but what you need for a full understanding of an information processing system is the final level, which is the implementation level. And what the implementation level is how is this representational level actually done, actually implemented in a real physical entity. So studies of the human brain and how the human brain codes memory in its different neurons and different activations. That's implementation stuff. How do memory cues, such as Post-it notes around your environment, help people whose memory is failing? That's implementation level stuff. How is anything that we do possible in the physical world? That is implementation stuff. So to make it a little bit more, give you another alternative example for this, anybody that is working in AI at some point has to come up with, how do we make this into a machine? How do we put it into a computer? That's implementation. So the implementation level, another word for it in psychology is neuropsychology. So part of it is neuropsychology. Again, I did that thing where brain equals mind. It does not. Part of it is neuropsychology. That's part of the implementation level. How does all our neurons actually make us able to do the stuff that we do at the representational level? How do external stimuli allow us to do things at the representational level? So just kind of that first example that I gave you of the Post-it notes to help people with failing memory, that is a good example of how your mind is not just in your brain. Your mind is anything that allows you to information process, including Post-it notes on the side of your wall, including your phone. Your phone, whether you like it or not, is part of your mind. And that's one of the reasons why I don't make students put their phones away, because I did a demonstration one time. So oftentimes, I'll just have a little tangent here. Oftentimes the psychology department, about once every 5 years, we're asked to give a presentation to the rest of the faculty on campus as to what is the mind of the incoming class going to be like, right? So what can they expect for freshmen coming in? And we kind of do that. We try to refresh it every 5 years. And we have people like Dr. Rodriguez talking about how your mind develops and frontal lobe activation, things like that. We have things like Dr. Ritchie talking about child development. And then we have me talking about the cognitive psychology aspects of it. And one point that I made was that your phone, you were raised with your phone. A lot of you had this very, very early. Smartphones have existed for longer than you have. And this has become a part of our information processing system. And to put this away for a lot of us is a lot of anxiety. I don't like not knowing where my phone is. I like having it visible because I have incorporated that as part of my mind. For my implementation, if you wanted to know how to implement my human mind, you would have my brain, you would have my phone, you would have a bunch of other things. So just to make you feel good about having your phone out, I did this demonstration where I asked faculty to close their eyes until I tell them to open their eyes and just see what it's like when you take part of your mind and you get rid of it, right? See what it's like when all of a sudden you can't employ some information processing systems that you normally do employ. And I told everyone, I will tell you when to open your eyes again. And I was planning on going a minute, and most of the faculty didn't last 10 seconds. They closed their eyes, and within about 10 seconds, their eyes popped up because that feeling of being cut off from part of your mind just got to them, and they were like, I'm not going to do this anymore, too uncomfortable, don't like it. So that's a really good explanation of why oftentimes when people put away their information processing systems, your phone, your laptops, and things like that, that's part of your mind. That's part of how you go through this world and how you do cognition. So again, implementation level, if we were to understand fully someone in our society and what their mind is like, we would have to understand their brain. We would have to understand their body. We would have to understand mental interactions with their environment, and that includes their phone. All right, aside over, back to the matter at hand. We talked about the computational level, what can we do? We talked about the implementational level, how do we make it physical? Now we're going to talk about the representation level, and that is the strategy that may be used And the reason we have may be used is because this is the real mystery portion of this tri-level hypothesis. This is what cognitive psychology is trying to figure out. And this is why we have so many different theories, because we'll say maybe we do letter recognition like this, and then we'll test it out and find out we're wrong. And then we'll say maybe we do letter recognition like this, and then we'll test it out and find out we're still wrong, but probably getting closer. But these are the strategies that we may be using. So what representations does a system use, and what processes does it employ to build and manipulate those representations? That's what we need to know at the representational level. So we've been kind of talking around this. It might seem obvious, but let's make it explicit. What is a representation? So we've been talking about, this represents that, that represents this. You have representations in your mind. What is a representation? Well, it's a hypothetical internal cognitive symbol. That just means it's something that exists in your mind, and it stands in for external reality. So it is your model of external reality that's in your mind. That's what we mean by a representation. So a stop sign, that could be external reality, right? So stop signs exist in the real world. You might represent that stop sign using internal symbols in your mind, such as lines, locations, and colors, right? So that is the external reality. What's outside? Your internal cognitive symbols, that is your representation. So internally, that is what a stop sign is to you. Externally, that's the reality of the stop sign. So a few more examples. External reality can be represented in a variety of ways. And there's a variety of different cognitive symbols that are possible. And as we saw last time with the train problem, the way you represent things, sometimes it makes things easier, sometimes it makes things harder, sometimes it makes things impossible. So it's important to know how external reality is represented in these internal symbols. So let's say that we have the external reality of two. So the idea of two-ness. We have two goldfish in this bowl. How do we represent that external reality of there are two things? Well, one internal symbol that we might use is the symbol, the numerical symbol for two that we all learned in our society. So we might say, hey, you know what? That's how we represent the number two or the idea of two in our internal cognitive representations. Alternatively, maybe we do something like this, where we represent two-ness in the external world as two circles in our internal world. On the other hand, maybe we represent it like this, right? And there are only 10 types of people in the world, those who understand binary and those who don't. So 10 is a way that a computer represents two, because that's the number two in binary code. So all of those are possible, right? All of those are possible internal ways of representing two. So our job as a cognitive psychologist is to figure out which way do we do it as humans, what's in our human mind, and we use the difficulties that we have, the challenges that we have, times when we get things wrong. Those are oftentimes our best indicators of what our internal representations actually are. All right, a few more examples just to kind of drive this idea home. Let's say that we got the external reality of the United States of America. So I keep saying external reality. Clearly, these are still models for external reality. So I can do this, the external reality of the United States of America, where we are right now. But it doesn't it's a little harder to understand. So I'm going to play fast and loose, but always keep that in mind. When we're talking external reality, we're talking about the real physical things out there. So we have the United States in the physical reality, and we represent that somehow in our mind. So most of you, if I asked you, hey, picture the United States in your mind, most of you would be able to do that. And that's because somewhere in your mind, you have an internal symbol that is representing the United States of America. So this is one possible internal symbol, and this is known, and we'll talk about this in chapter 10, this is known as an imagery representation, where the way that you represent external reality has a lot of the same features as the actual external reality. So that's an imagery representation. So that's one way to represent the United States of America and the cities that are in it. This is another way to represent it. So you could have an internal representation. This is called a propositional representation, where you just say, hey, Los Angeles to New York, 2,700 miles, New York to Dallas, 1,500 miles, Dallas to Los Angeles, 1,400 miles. And that is the way that you represent, say, the cities in the United States. And the reason that we're trying to figure out which of these representations do we use is because they make certain behaviors possible, they make certain behaviors easy, they make certain behaviors difficult, they make certain behaviors impossible. So for example, if I am using this representation and I have to answer the question, which of these three cities is the most easterly city? Is it Los Angeles, is it Dallas, or is it New York? With this representation, super easy. You know what east is? You can just look at it and say, you know what? Boom, New York. New York is the most eastern city out of those three. If I'm using this representation, good luck, right? I don't even have that. It's impossible. That behavior of saying New York is the most easterly is impossible with this representation. On the other hand, if I said, what is the driving distance between New York and Los Angeles? Well, here, that question becomes very difficult because I can see the driving distance and we got that little legend, it's a little cut off, but we got the legend down in the bottom left. So with this representation, we could answer that question, but it would take you a long time. On the other hand, if we had it represented this way, then we would very easily say, oh, that's 2,790 miles from Los Angeles to New York. So what you're going to see when we start doing the Cog Labs and when we start taking a look at the experiments that are done in cognitive psychology, one of the big measures that is used is reaction time measures. And how long does it take you to answer certain types of questions? So in this case, if we were using reaction time measures and I asked you, hey, what is the distance between Los Angeles and New York? And it took you minutes to come up with the answer, that is good evidence that you have a representation like this in your mind. On the other hand, if it took you seconds to come up with the answer, that's a good indication that you have this type of a representation in your mind. So that's one of the reasons why reaction time is a very, very powerful thing that we're going to come across over and over again in cognitive psychology. And you've already had a taste of that because in that train problem we went over in the last class, if you were able to, if you used that as a distance problem, it was going to take you hours. If you solved it as a time problem, it literally took you 30 seconds. So those different types of representations have huge impacts on how we behave and what we're able to do in the world. All right, so the representations used influence the type of processing that can be done. As I mentioned before, we saw that with the train problem from last class. So again, to try to understand this, the representational level, we want to know what representations does the system use? Is it an imagery map? Is it a series of propositions? And then what processes does it employ to build and manipulate those representations? Is it manipulating distance or is it manipulating time? Are we doing manipulations of our representations of distance or are we doing manipulations of a representation of time? That's what we're trying to understand in this course. That's what we're doing at the representational level. And as I mentioned before, representational level is going to be 98% of what we do in this course. 2% is going to be computational, computational level. And then if you want implementation, then you would want to take a neuropsychology course and maybe an environmental psychology course as well. But implementation is going to be outside the scope of this course. All right, last topic we're going to do today, we're going to kind of take everything that we've seen and just sort of go through an example, kind of a typical kind of study and theory that came up historically in cognitive psychology. And that is going to be about letter recognition. So we're gonna get to this when we get to linguistics, but the ability to communicate verbally is borderline magical. The ability to read things is almost fully magical. So when you think about this, you could write something down. People have written things down, and 2,000 years later, people have understood what they wrote. That is literally like cognitive time travel. So our ability to recognize letters is something that, and read is something that it's very commonplace. Very few people have an inability to do that. But sometimes I think we sort of forget when things are commonplace, just how magical they are. And if you ever want to really kind of delve into the almost magical, mystical things that your human mind can do, take a look at the history of artificial intelligence and look at what they found difficult. And what they found difficult were not the things that we thought they were going to find difficult. So advanced mathematics, that was solved decades ago, right? The ability to, what am I thinking? The ability to do calculations very quickly, which we might find very difficult. That was discovered decades ago. But the ability to recognize a picture, they still can't do that. That's still how we tell who robots are and who robots aren't, right? It's like, which one of these pictures has a bicycle in it? And the AI is still, you know, do you want to do some advanced mathematics? I can do that. So anyways, yeah, that was another aside, sorry. We're going to talk about letter recognition. Sometimes it's just important to kind of step back and understand the magic of what our minds can actually do, even when it's simple things that little children can do. Doesn't mean that it's easier. It actually probably means that it's way, way more complicated. All right, so Mars tri-level hypothesis. We're going to go through it little piece by piece, not the implementation level. We'll start at the computational level here. So the first thing that we want to do is, in conceptual terms, we kind of want to establish what it is that we are able to do. So I'm going to go through a short demonstration here. And what I would like you to do is, when I put a letter up on the screen, if you can just call out and identify it, and let's see what our human minds can do. All right, so we know that we can recognize R, F, Z, and P. And we know that I can remember that we can recognize R, F, Z, and P. So that's a computational level. That would just be a whole bunch of us determining what it is that we can recognize, what it is that we cannot recognize, what are the letters that are within our ability to process and recognize. That is your computational level. Now let's turn to the meat of cognitive psychology, the representation level. So how do we recognize the letter R? What is the strategy that may be used in order to recognize the letter R? So we'll start off with that one. And we'll start off with a theory that was a very early theory of letter recognition. And I won't lie to you, it's wrong. It just doesn't hold up. And we'll see by the end, like a spoiler alert, it doesn't hold up. But one of the first theories that came about was a template model. And the template model basically said, well, we have this thing in the outside world that's shaped like that. And that is going to get input into our mind via some image processor. So it goes into this image processor, and that's going to get input into our mind. And some of you might be thinking, well, what about that image processor? How does that work? That is not the focus of this. So a lot of times in these models, you'll see that they kind of gloss over how certain things are done. It's because they're trying to explain a very specific aspect of it. So it's basically saying, well, if we have the image of it in our mind, how do we then match it up to memory so that we can recognize the letter? And again, just getting into that image, that's also implementation-wise, very, very difficult. We have just kind of cracked those codes maybe 5-6 years ago. So anyways, so the image comes in, and then it gets compared to the template. And then if it gets compared, if it gets discovered in the template, or if it doesn't get discovered in the template, we end up with a decision that is made as to whether we recognize the letter or not, and if we do, which letter is it? So step by step, we see that thing in the outside world with the stick and the round part and the little slash. And that goes into our image processor. Excuse me. And then that gets compared to our template. And basically the idea is that it goes through the entire template here. And I did change let's get that back there. So it goes through the entire template there until it matches the image with something in your template. So your template is made up of all these little entries. These are all the letters and numbers that you know. And when that image gets matched up to that template, then you make the decision and you say, you know what? Yes, that's an R. And when they were trying to figure out, well, how would this be implemented? One of the proposed ideas of this representation is that the image needs to match exactly to the template. You have this template in your mind, you have this image that you see, and that image has to match, kind of like your left hand on top of your right hand. It's got to basically match point for point, and that's when you understand that you're seeing that R. So in this case, that is the template model, and that's how that would work. And then the alternative model that we're going to talk about today came out a little later, and this is the pandemonium model, and this is the one that says you have demons in your mind. So what are these demons doing? Well, this was a model that was proposed by Selfridge back in 1959. So this is like 66 years old by now. So you can, I point that out because you'll notice how some of the ideas that he proposed have become more and more commonplace in terms of how we think information processing is done. So it's sometimes hard to appreciate the historical importance of something like this, but we are going to go back and revisit it. So once again, we have our external reality that goes into an image daemon, and then that image daemon projects it onto a screen, a television screen, and in that room where that TV is, we have a whole bunch of feature daemons. And these feature daemons each have a little symbol on their chest or on their bellies, and when they see that symbol, they get very excited. Actually, not excited, they get very agitated. They get very, very angry when they see the symbol that is on their bellies. And these feature daemons are not the only daemons in your mind. They are also cognitive daemons. And these cognitive daemons each represent a letter. In this case, we're going to keep the model simple. We're not doing all 26 letters. We only have the R, P, F, and Z, the ones that we established computationally that we can understand. And then finally, they send information out to a decision daemon. And this is the basic components of this model. The last thing that we're missing are the connections between the feature daemons and the cognitive daemons. Because each of these feature daemons can talk to certain cognitive daemons, but it cannot talk to all the cognitive daemons. Is there a question? No? All right. It cannot talk to all cognitive daemons. You can see there a failure in my representation and strategies because I thought I saw a hand up, but I wasn't really sure if it was a hand up. So that hand up recognition kind of failed. And if we delved deeper into this, we could probably figure out how I represent hands up. But anyways, back to the daemons. So that first daemon with the vertical line on its belly, it talks to the R, it has connections to the R, it has connections to the P, it has connections to the F. It does not talk to that Z cognitive daemon. So it's got connections to R, P, and F daemons, but not the Z cognitive daemons. And that one with the curve on its belly, it talks to the R cognitive daemon. It has connections to the P cognitive daemon, but not to the F and not to the Z. The one with the slash going to the right, it talks to the Z cognitive daemon, no other daemons. And the one with the slash going to the left, that talks to the R cognitive daemon and no other daemons. So those are the links between the feature daemons and the cognitive daemons. And this was the proposed representation for how you recognize letters, how your human mind recognizes letters. So let's go through this step by step. So we start off with the R in the external world. That gets picked up, perceived by the image daemon. So the image daemon you see there has that R now on its belly. It has that external reality basically projected onto itself. And it says, you know what, I'm going to send this via my link to the TV. I'm going to project this on the TV in the feature demon room. And the feature demons, they start to, where did my feature demon go? They start to disappear. Okay, I don't know where my feature demon went. Let's say that that feature demon stays there, all right? That feature demon with the vertical line, it sees a vertical line on the TV and it starts getting very agitated and very angry and says to itself, I gotta tell people about this. I am outraged and I'm gonna post on all my socials how outraged I am that this vertical line has shown up on my TV. So it gets outraged and it starts telling everybody that it knows. So it sends a message to F and it says, hey, F cognitive demon, I am outraged, absolutely outraged. I see a vertical line. And it sends a message to the P demon and says, I am outraged, outraged, I tell you. And it sends a message to the R demon and it says, I am outraged. I can't believe this TV screen has this on my screen. So outraged that apparently it imploded. It should still be there. Spoiler alert, computer's not going to fix my errors. Okay, so we have that demon, and that demon has vented to all the demons it's connected to. Then we have the next demon, the demon with the curve on it, and it sees on the TV a curve as well, and gets very agitated, and gets very angry and outraged, and says, I need to tell everybody that I know about this. So it disappears and sends a message to the P demon and says, you know what? I see this curve on the screen. I can't take it. Outrage. And it sends a message to the R demon and says, curve on the screen. Outrage. Can't stand it. We get to the next demon, the demon with the slash that goes up and right. And that demon with the slash that goes up and right is saying, you know what? I'm fine. I'm cool. I'm not bothered at all. Whatever that thing is, doesn't bother me. And then we have that last demon there, who's going to disappear right now. And it has a slash going from the top left to the bottom right. And it recognizes, it sees a slash that goes from the top left to the bottom right on the screen. And it says, I am outraged and I'm going to tell everybody that I know, but I only know one person. I know the R demon. So I'm going to tell the R demon, you know what? I am outraged. This is not cool. So then all the outrage gets communicated. And now the cognitive demons are talking amongst themselves. And they're like, hey, you know what? Something must have popped up on that screen. And the R demon says, you know what? Yeah, something popped up because three feature demons got in contact with me to tell me how angry they are. And then that P demon is like, oh, really? 3? Well, only 2 actually got in contact with me. I only got 2 posts of outrage. And the F demon is like, oh, well, you got 2? I only got 1. Just the one feature demon contacted me about how angry they were. And then the Z cognitive demon is like, well, something on the TV? I didn't know. I didn't get any posts about this. So we have 3 feature demons talking to R, 2 feature demons talking to P, 1 feature demon talking to F, no feature demons talking to Z. And the decision demon is looking in on this. And he said, oh, okay, 3 feature demons called the R cognitive demon, only 2 called the P cognitive demon, only 1 called the F cognitive demon, nobody called the Z cognitive demon. You know what must be on that screen? It's got to be an R. And that is how the pandemonium model explains letter recognition. All right, any questions on that? Yep.
What if there was something like a lowercase p, then both the uppercase P and the lowercase p would have a curve and a line message?
Exactly. And we're going to get there in just a moment, but that is a very, very good point. And that is also something that that's one of the reasons why cognitive psychologists need to have that computational level kind of sussed out so that we know, hey, which ones are confused, which ones are not confused in the real world. And then we need to have our models also be as confused as humans are in the real world. Because let me just put it this way. If you come up with a representational strategy that outperforms humans, then that's not how your human mind works, right? We need to come up with representational strategies that behave like humans do if we want to understand humans. If we're programming computers and all we want to do is just make the most intelligent computers we can, Then we're just looking for the best strategies. But as psychologists understand humans, one of the things that we need to know is that computational level. What can we do? What can't we do? Because if we come up with a theory where, you know, that's better than what we actually are, then it's the incorrect theory. The question?
Yeah, so this pandemonium level, I guess, kind of says, or kind of explained that, like, this is only coming from like cognitive recognition, right? Like, this doesn't apply to learning new things. Like, if you had like a letter from like a Chinese or Mandarin alphabet, like the pandemonium model wouldn't really work until you learned what those like characters mean, right?
Exactly, exactly. So that's a very good point, that this pandemonium model represents what you know and doesn't necessarily represent how you would learn that. But let's just take a moment to kind of unpack that. And this is a great example of models lead you to ask certain types of questions, right? So remember we mentioned that if you have a certain model, you'll ask certain types of questions. So I'm not going to back up to the template model because that was many slides ago. But you remember the template model, you come with a template. And that template has all the letters on it. If you wanted to learn new letters, say you were learning a new language and it was in, you know, it was in kanji language. You can tell how many languages I've learned. Let's say that you're trying to learn a new language. Well, then you need a new template, right? You would need to either create a new template or add to the template that you're already using. That would be the way that you would learn the new letters. So we might ask ourselves as psychologists, well, how would we create those new templates? And how long would it take to create those new templates? Here, if we were to expand this to a learning model of letter recognition, we don't need templates. So we wouldn't even ask, how do we create new templates? What we would say is, how do we get new connections between certain daemons? And how might we come up with a new feature daemon if we need a new feature, right? If we have a new, a new line that needs to be represented. And then how do we create those connections between new cognitive daemons? And that would be the questions that you would ask in that sense. Yeah. All right, so we have seen now two ways that we can possibly understand how do we recognize the letter R. So we have the template model and we have the pandemonium model, and they seem to be doing pretty well at this point. However, what about different fonts? What about recognizing letters that are different fonts? So we go back once again to the computational level. And we have to ask ourselves, can we recognize different fonts? So once again, we'll do this exercise. So call out the letter as soon as you recognize it. Here we go. All right, so computational level wise, we now know that we can recognize in this new font, we can recognize the letters R, we can recognize F, we can recognize Z, and we can recognize P. So we have the computational level, at least for those 4 letters, figured out. Now what about the representational level? So we go back to the template model. And now we have this new font in the external reality. We have the same template model. And one of the things that I'll just mention right now is that when you're making models of the human mind, you always have to be very aware of what assumptions you're bringing in from the outside world and what sort of ideas are you bringing in from the outside world. So this template model, this was very early on in sort of letter recognition theories. And during this time, this was when, during the heart of the industrial age. That's the idea of the template. So the idea was that literally these letters were stamped in steel, quote unquote, human mind steel. They were stamped in there. And then you would almost like a jigsaw puzzle try to fit your letter into a slot. And if you fit it into the slot, that would be your recognition. So remember that when we go through this example, because now we have an external reality in a new font, but we have a template that has very predetermined mechanistic type slots. So once again, the model in this case would say, all right, that external reality goes into the image processor. And that image processor sends it to the template, and we search the template. And we're looking, and we're looking, and we're looking, and we're looking, and we're looking. Did we find it? No, we didn't. So we keep looking, 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 and we don't see it. Because we don't have any kind of indented, pressed in area where that external reality now matches up with the template that we have. So our decision is that we have no idea what that letter is. So that was a template model. And as you can see, the template model fails. It completely fails because we can recognize that as an R. And the template model says, no, you can't. If you're using this template model, you can't recognize that new font. So therefore, this cannot be the way that our mind represents letters. We don't just have a series of templates that we match letters to. Otherwise, you could propose that, well, we have one for every single new font. But what that means is that as soon as somebody comes up with a new font, you would just say to yourself, well, I have no idea what that is. And it might take you a week, a month, maybe a few months to learn those old letters in that new font. Clearly, that's not what happens. Clearly, the template model just doesn't hold up. What about the pandemonium model? So once again, we have that external reality. We have our image daemon, our feature daemons, same feature daemons. We have our cognitive daemons. And then we have our decision daemon, and we have all our connections. So this is the exact same model that we set up previously. And now we have that external reality projecting itself onto the belly of the image daemon. And then that gets sent up to the TV in the feature daemons, room. And once again, we have our disappearing daemons if they see something that is the same as what's on their belly. So the vertical line sees vertical line and says, you know what? Agitated contacts all of its connections and lets them know that I'm really, really angry. That once again, I see a vertical line. And then we have the one with the curve on its belly, and it says, you know what? Curve right up there, and sends information and hosts of anger to all of the connections that it has. And the one with the slash is going from bottom left to top right said, I'm totally fine. I'm not agitated at all. But the one with the slash from the top left to the bottom right says, you know what? I see it. It's got a little curly thing on the end of it, but part of that is that slash that I hate so much to see. So it gets agitated and it contacts every cognitive daemon that it has connections to. And then once again, the cognitive daemons are comparing notes. And the R cognitive daemon says, 3 feature daemons have reached out to me about how angry they are. The P cognitive daemon says, I only heard from 2. The F cognitive daemon says, I only heard from 1. And the Z cognitive daemon had no idea anything was going on. And once again, the decision daemon takes a look at this and says, you know what? That must be an R that we have just seen. So the pandemonium model can actually handle the introduction of different fonts as long as certain aspects of the letter stays the same. The font can change, but you will still get recognition of those letters. All right. So the last thing that we're going to do with this is just kind of leave you with a couple of questions and just an overall kind of summary here first, and then a couple of questions with the pandemonium model. So what can we do? We can recognize our template model and pandemonium model. Template model says that we can recognize our pandemonium model says that we can recognize our. So each of those are still possible contenders at this point for how our minds might work, for the representational explanation of how we recognize letters. However, recognize the R in the second font. Template model says that we cannot. Pandemonium model says that we can. So the pandemonium model matches up with our computational level analysis. The template model does not, meaning that maybe the pandemonium model is the way that we represent letters in our mind. So notice that out of the two, the pandemonium model seems the sillier of the two. Because it's actually saying, yeah, we got little demons in our mind and they're sitting in TV rooms and they're getting angry, so they're phoning their friends. You know, you take a look at that compared to the template model, which has that very kind of mechanistic industrial feel to it. And the template model seems like a more serious model, but the pandemonium model matches what we actually are able to do. And then this pandemonium model then suggests questions that we can ask. So this was what you brought up earlier. I didn't think about the lowercase b. I actually thought about, was there going to be confusion when you're looking at p? So given the model, and this we're going to leave as a sort of take-home challenge. I'll upload these the PowerPoint slides today so that you have these so that you can work on it. But a really nice way of kind of testing to see if you understand what we have been talking about in this pandemonium model and how it kind of works, and whether you understand what it works, is take a look at whether the pandemonium model in this case says that we can recognize the letter P, or does it say that we are going to be confused for the letter P? Other questions that we can ask is, what happens if we lose some connections due to brain trauma? So will there be confusion now when looking at the letter R? So let's say that we had this represented in our brain, and then all of a sudden we had some trauma that occurred to our brain, and the connection between that final slash feature demon and the cognitive demon R, let's say that that connection got severed and it was now gone. Now can we still recognize R's? Or now are we going to be confused as to whether or not we're looking at an R or we're looking at some other sort of letter? So those are two challenges that I'm going to leave with you. We're going to take them up next time that we meet. But again, try to work your way through it. It'll be a good exercise in sort of solidifying your information for the pandemonium model. And one last thing that I'll mention about this model, and one of the reasons why I think it had a large influence, is that one of the things that we didn't really mention, but it does impact which models sort of get more attention placed on them. If you have a model at the representational level, and it can very easily go to the implementation level. If you have an idea very easily about how you can take a representational level to the implementational level, that model is much more likely to get a lot of attention than if that connection is much more difficult. So the template model, if you were to implement the template model in a brain, that's very difficult, because a template model looks nothing like a brain, right? It looks nothing like the connections in a brain between neurons. But if you got something like the pandemonium model, then you're saying to yourself, well, we can think of our mind as if we have these demons in our head. But notice, if we want to implement this, those demons and their connections, that's a lot like neurons, right? And the neuron connections that we have. And, you know, that all of a sudden makes it much more seductive, much more likely that a lot of attention is going to be placed on it, because now it lets us know, okay, now we have a way to go from that second level to the third level representation to implementation. So that was just my final little aside, just to let you know about another property of models and another positive aspect of models. Sometimes when you get a model that can explain what we do at the representational level, sometimes the implementation of it becomes much more straightforward versus other models. All right, and that, I promise, is it for today. Thank you so much.